In the previous video, we established how we go about the process of what it is we're going to load, and more importantly, why we're loading that. In other words, we've got a specific application in mind, and we're tweaking the load to the application. So it's the right tool for the job, so to speak. So in the second step now, in this series, we're going to set up our dies. Now, if you don't get this correct, you're going to have nothing but trouble. So it's not hard, but just follow along, and it doesn't matter if you're doing it on a turret press, a single stage, a progressive machine, whatever. The procedure I'm going to show you is how it's done regardless of the press you happen to be using. So this is an RCBS 3-die carbide set, and they write, well, carb, which is carbide, and it comes in RCBS in a gray box. Another manufacturer will have different packaging. So just look for the abbreviation carbide, and now you know you've got carbide dies, as opposed to a steel die set that does not have that carbide ring. The carbide is that shiny little ring inside the sizing die right there. And what that does is it's a very hard surface smooth material that allows you to put a casing inside the sizing die, and it'll squeeze it back down to factory spec without having to put lube on the casing. Now, I'm a big fan of putting lube on the casing regardless, just because it makes it easier, but if you have carbide dies, you don't necessarily have to. So just so you're aware of that. Now, the way you set that up, you got the shell holder, which in RCBS's case happens to be a number 30, which they conveniently put on the box. Another manufacturer's shell holder is going to look the same, but is probably going to have a different part number. The different manufacturers are interchangeable from brand to brand, as long as it kind of looks like this and it has that little base on there. They're going to have a different part number. If you're not sure, look at the manufacturer's chart that will tell you you need our part number, whatever, for 41 mag in this instance. The shell holder snaps into the top of the ram, which is retained by a spring that protrudes through the slot. In the old days, they had a set screw that went into the side. Both work great, it does the job, but it is a little bit more convenient if you've got that little wire spring protruding into the slot. So you run that all the way up, and you're going to screw down. Let me show you this. I didn't show you this. You see how that decapping pin is protruding actually a little more than 1/4 of an inch beneath the bottom of the die? It needs to be low enough so it'll knock out the old primer. If you don't have it low enough, it won't necessarily knock out the old primer. So we run that at least 1/4 of an inch, maybe a little bit more, beneath the bottom of the die, and then set your nut on the stem so that doesn't walk on you. Now we screw this down until it makes contact with the shell holder, and then I'm going to set my lock ring. I'm going to stop right there. Now, on some manufacturers' sizing dies, they're going to tell you, find the top of the shell holder, screw it down until it makes contact, lower the ram, and then screw it down a little bit further. That's called overcam. Now, it's typically going to be a direction you would see on a bottleneck casing. On a straight wall casing, not necessary. In fact, if you didn't go all the way down on most, not all, but most of your revolver rimmed cartridges, it's going to go in the gun just fine regardless. So we screwed it down till it makes contact with the shell holder, and then we set the lock ring. Now, one other point I want to bring up, if you are using a turret press, I want you to see here on the Redding T7, the window back here is not particularly low or tall, if you want to think of it that way. If you have your decapping pin down too low and you go to spin the head on that because you want to do something else with your decapping pin protruding too far, it's going to hit the bottom of that window and you just bent your pin. Not that I've done that 100 times because I wasn't thinking. So we've got a casing that we're going to put in here, and we're going to run that up into our sizer. We lower it, and we're going to grab our case gauge, ammo checker, or if you don't have either of the above, then you can just grab the revolver and try it in the chamber. but it should drop right in and sit flush with the top, which it does. And then when you flip it over, it should fall right out with no issues. Now we know the casing is sized properly. The sizing decapping die is set up, ready to go. Your lock ring's tight, the nut is tight holding the stem. You're done. In the second step, we need to flare the mouth of the casing. Now, in the first step, the mouth of the case was squeezed down too much to where we cannot set a projectile on there, take our fingers away, and then run it up into the seating die without it falling off or tipping over. So we're gonna, in the second step, we're gonna run that up this mandrel inside the flaring die in step number 2 until we got just enough flare on there so we can set the bullet on top, take our fingers away, and it'll stay put. Now on the RCBS, you've got a step right here, and then it hits that aggressive inclined plane. This is kind of the sweet spot where it's opened up just enough for a jacketed bullet like I'm loading here from Sierra, 170 grain jacketed hollow core. It's a it's going to be bore diameter, as opposed to, say, you're loading a powder coat bullet, a high-tech coat bullet. A lot of your plated bullets, or just, your standard cast bullets, will be a thou larger than your standard jacketed hollow core. And in Sierra, they're sized exactly 41, so they're 410. Your cast bullets, plated bullets, whatever, would generally be 411. Some might even be 412. Just so you're aware of that, because you go to seat the bullet and you notice that plating or powder coat is piling up on the mouth of the casing as you seat the bullets because there's not enough flare in there. So we're going to use the projectile that we're going to load as our gauge to make sure that there is an appropriate amount of flare. We're not going to scrape the bullet as it goes in, but we don't want to overwork the casing, so it's going to back and forth motion, work hard in it, and it's going to crack sooner than it might otherwise. So we get the die started in the top of the press. We run a casing that we've already sized up into it, and now I'm going to screw down the die on top of the size casing, and I feel resistance as it's going into there over that mandrel, but I get to the point where the mandrel is getting wider, wider, wider. That's the point at which the flare function that I'm looking for is beginning. So I uncover the resistance, I lower it, and I grab the projectile I'm going to load, and I'm using this as my gauge as to how much flare. Now remember, the idea here is you flare just enough where you can set the projectile on top. You take your fingers away, it stays put. There's not a great big gap in there, and it's just right. So I'm going to make sure my lock ring is tight, the nut that retains the flaring mandrel in the center of the die is tight, so nothing's walking around on me. Now in the last step, which with the RCBS dies, we'll seat and crimp in one operation. Inside of this, I don't know if the camera's going to pick it up. You see that ring? You can see the ring pretty clearly there. It's a dark ring, and then you see the threads behind it. That's the crimp function. So to set this thing up properly, we're going to start that into the top of the press. And then I've got 2 different stems, seating plugs that I can use. Now, the different contours, it's kind of obvious if you have a flat point or a hollow point, you probably want to use the flat, and then the other one's cut sort of round. So if you're doing a round nose, probably going to use the round. Doesn't necessarily always work out that way, because sometimes the seating plug is cut such that it will touch here on the ogive before the bottom, the top, the mayplat of the bullet makes contact with the center portion inside your seating plug. So what I do to make sure I've got, of the 2 to choose from, the better of them, I take the bullet I'm going to load and I put the seating plug on top and sort of wiggle and jiggle, compare that fit, how it feels on there, compared to the other one. Now this one is kind of sloppy and is flopping all over the place. Really no stability there at all. So I'm going to go with this one. Now this one happens to be the one that's flat. Doesn't always necessarily work out that way though, so just so you're aware of that. So I'm going to start the stem into the seating die. I'm going to put the size casing that I flared into the shell holder, and I'm going to run that up. Now I'm going to screw down the body of the seating die until it stops. Where it's going to stop, you know that ring that I just showed you, that dark ring inside the die? That's where the crimp function begins. That's where it just stopped. So I'm going to use my seating stem to get close to the correct overall length that I wrote down here from the Sierra manual that they're using, because it is a Sierra projectile of 1.570, which is going to put me there at the top of the cantilever. These lines that run up and down on it, right there. I want to roll the mouth of the casing right onto the top of the cantilever, which is also getting me just below the ogive. The ogive on the projectile is this part where it starts to angle upwards. So you've got the bearing surface, the cantilever, then the ogive, and the top is called the mayplat. We're going to roll the mouth of the casing at the top of the cantilever, which is just underneath the ogive. So what I'm going to do is I screw that down on top of the size flared casing and put my bullet on top. See, set that fairly straight and run that up. Now, again, I start screwing down and I can feel I'm getting some resistance there. So I'm going to keep going with the stem until I've got probably halfway up that cantilever. And then what I'm going to do is I'm going to turn down the body of the die, because the more I do that now, it's going to start rolling the mouth of the casing into position. So I'm going to measure to see where I'm at. I know I'm pretty close, but I want to make sure I'm within a couple of thousandths of where my overall length needs to be. Okay, so I'm pretty close right there. So I'm going to make sure the stem lock nut is secure. And now I'm going to loosen the lock ring for the body of the seating die. I'm going to take my dummy round that I am now making, and I'm going to put that up inside of here, and I'm going to start screwing this down a little bit more, set the lock ring so I don't overrun it. Now as I do that, hopefully this will show up pretty well. You see how the top of the casing is shiny now? What's happening is the mouth hit that ring and is rolling inside, and that's where the shiny mark is coming from. And I feel the resistance that I'm getting, and I'm thinking, boy, that's really close to exactly where I want to be right now, just on the visual looking at it. And I'm just about to the very top of the cantilever, so I know, yeah, I'm like 2/1000ths away from what the overall length is. Now, this is a soft top projectile, and I've been fiddling with this thing, so I've deformed it. Now, this is going to give me a length that's actually a little shorter than it truly is, because I mushed the top a little bit. So I'm going to take that down using this a little bit more than I might otherwise, and then I'm going to stop right there, make sure my lock rings are tight. Yeah, when I run that up into the seating die now, boy, that feels, I just know from experience how much resistance I should feel at the top when I can feel that crimp taking place. And my overall length, now this one I've overrun it by 6/1000ths, but I think I've got more than probably 6/1000ths in a mushed mayplat, because I've been fiddling with this one too much. But you can see, look at that shiny part right there. So I can seat and crimp in one operation. Now here, I can take this and just use it as a dummy, so the next time when I go to set up, I can just screw this down, my seating die down on top of my dummy round. I'll leave that right there in the box. And now I'm all set to load 99, not 141 mags. And we'll get into the actual assembling of the cartridge process in the next episode. Stay tuned to this bat channel. Happy trails.